Thanks to remain with us in the last talk of the day, and thanks to the organizer of this webinar for the invitation. Today, I will talk about some knowledge and challenge we have to study ocean acidification in Latin America. There are 32 countries with coastal and oceanic areas in the region, and from them, only 10 works in ocean acidification. So we need to include in our network more countries, particularly from the Caribbean islands. Also, our capacity building among countries and scientific backgrounds are different, so we need to work on it. In our community, there are less than 200 scientists to cover a huge amount of area, about twice the size of South America continent. In the region, we can find more than 100 marine protected areas and different tropical, subtropical, and polar ecosystems, including important hotspots of biodiversity such as the Galapagos Islands. There are two objectives that we need to achieve. One, to have healthy and functional ecosystems, and two, that the governments include in their agendas as a priority ocean acidification in order to mitigate the impacts on the ecosystems, the people, and the economy. In scientific terms, we need to solve important questions like what is happening in the ocean, the biological impact of pH, how this will affect us, and what we can do to solve the problem. As a scientist, we cannot work alone. We need to include the people and the politicians. As a society, we need to work for a common goal, to raise awareness of the risk and value of our natural resources. We also need politicians and the money to achieve our two objectives. In Latin America, we need to address some important gaps of knowledge at different ecological levels. Additional research is necessary to understand the role of evolution, genetic variation, adaptation, and plasticity in order to explain different trade-offs and the tolerance response that we have found in our species. Also, we need to understand why populations show different spatio-temporal responses to pH. We need to identify which species have pre-adaptive mechanisms to low pH, which species are at risk of extinction due to corrosive environments. To understand ecological key processes like species interaction, the effects of low pH in the trophic chains, and the vulnerability of different species across the taxonomic spectrum. We need to be able to identify which ecosystems are at risk of collapse according to the IUCN. What ecological service we will lose in the short term and medium term, and how this will affect our lives. We need to search and understand how the ecosystems are changing in structure, composition, and functioning due to low pH scenarios and global warming. We require scientists to explore at all these ecological levels, since this is the key to look for solutions to solve the ocean acidification problem and to save our coastal and ocean ecosystem for future generations. Now I will talk about what we have done in Latin America in terms of monitoring, experimentation, and modeling, and highlight some bias and knowledge gaps. Our program has focused on studying the variability of the carbonate system, particularly in the coastal zone. Although our efforts in the last 10 years are important, they are insufficient taking in account the large extension and heterogeneity of our region. So we need to improve our spatio-temporal coverage. Some bias in the monitoring programs are to focus mainly on natural acidic coastal sites. So we need to increase our capacity to monitor open ocean and sites with high pH values to use them as a control sites. Another problem we have is our spatio-temporal data resolution and accuracy that not always allow us to do a robust analysis of the data. So we need to implement programs to standardize protocols and to check for data quality control. However, we need to take advantage of the information we already have, particularly from the Cariaco station at Venezuela that has more than 20 years data. In addition to improving our ability to monitor the open ocean, we need better tools to measure the high spatio-temporal variability of the carbonate system in our coastal ecosystems. Key information to define the right pH values to use in our experiments. Also, we need to guarantee the long-term monitoring programs in which we can measure multiple key parameters, multiple coastal and oceanic sites, new ecosystems and habitats, as well as control sites for relative comparisons. Also, we need to improve our knowledge about the oxygen minimal zone, one of the largest in the world, and its potential socioeconomic and ecological impacts. Additionally, we need to improve our understanding of the climate-ocean CO2 exchange and their main drivers, and the role and global contribution of Latin America in terms of the uptake of atmospheric CO2. In Latin America, we have 11 laboratories to conduct experiments with ocean acidification. The response of most of the species has been a net negative effect related to low pH, where the organisms spend more energy and exhibit a trade-off with survival and reproduction. Some bias in the experiments are to give priority to species of economical value and also to quantify simultaneously few independent variables. So we need to improve our ability to reproduce in the labs what the species experience in the field and go further. I mean, to use lower pH scenarios to simulate the real stressful conditions that the organisms face. In the field, we are measuring the natural pH variation, and we are using that information to select the right treatments values. We also need to study key ecosystem, species, and taxa whose presence ameliorate the ocean acidification impacts. Also to include in the experiment multiple stressors different than the ones that we are testing right now. We have serious limitation in modeling in terms of building the model or generate prediction. This is because we have in Latin America few scientists working in the field and few field data to fit the models. So we need to increase our capacity for modeling and predictions. To achieve that, we require more scientists and long-term spatiotemporal data. Now, why we need all this knowledge in Latin America? To support conservation actions like management and for the design of marine protected areas. To support our society with knowledge, in that way they can take informed decisions, and with that together, we can push forward local or regional policies. To support the economic sectors, public or private, and also to provide the scientists, the scientific community with the new knowledge generated in Latin America. In terms of communication, we have identified a limited scientific impact derived of our knowledge due to miscommunication. So we need to provide efficient and timely scientific communication to involve people and politicians and to promote actions. In order to reach the audience we need to achieve linkage with politicians, they need to recognize that there is a problem and they need to support long-term commitments. Also, our knowledge needs to support all politician actions to achieve the sustainable use of resources and ecosystems. We need to reach a larger audience and build a stronger network. We need to generate awareness of the value of nature in the young people. We need to show them that we are part of nature. All this to carry out citizen actions. We need to inspire the new generation of professionals to preserve nature and to look forward for creative solutions. The major problem of any scientist or network is to obtain research funds. In this case, enough money to implement in the near future the Latin American Action Plan on Ocean Acidification. So in order to do that, we need to provide our countries with facilities, laboratories, equipments. We need to train a new generation of scientists, technicians, and professionals, particularly of different disciplines, to deal with politicians and other actors in our territories. The goal with all this capacitation is to obtain standardized techniques, quality data for comparison, and also to include them in international repositories. We require to expand our collaborative programs, to build low-cost, reliable equipments, and develop certified reference materials in Latin America. Additional support the coastal zone observing monitoring system to fill the geographic gaps of information. Furthermore, we need to measure the economic and social vulnerability to ocean acidification from the tropics to Antarctica. We also require money to create a regional treaty to mitigate the effects of ocean acidification, to write large-scale projects with the socio-ecosystemic approach in order to promote cooperation and to compare responses between countries. We need to improve strategies for accessing and sharing data within and between countries, to create a regional database to house free information following the FAIR principle. Finally, we need to improve the Ocean Acidification Latin American Network. That's all. Thank you very much for your attention, and later on I will be pleased to answer any question.